Hello. Okay. Today we are going to try to finish the data visualization micro course on Kaggle. Let's go. Load and examine the data. Okay. Okay. So this. Load the data. PD.read CSV. In the file path. Oops. Fill in the line below to read the file into a variable candy. Candy. Okay. Oh. What I don't see here. There's something here that I don't see. Path to the file. So we always start PD. Is it something else? No. Read CSV and then parentheses and then the file path. Candy file path, that's the name. Or let's do this. Okay, unexpected column. Ah, use a Python command to print the first 5 rows. Candy data. Okay, so we have competitor name, chocolate, fruity, caramel, peanutty, almondy, nougat, crisped, rice wafer, hard bar, pluribus, sugar percentage, price percent, percent, different attributes. Okay, I didn't understand price percent because shows the price per unit relative to the other candies in a data set. Relative to the other candies, like average of those candies, some of those candies, seems like not some, seems like they're like one. Other candies. Okay, anyways. Fill in the line below. Which candy was more popular with survey respondents? Three Musketeers or Almond Joy? Three Musketeers, 67. Almond Joy, 50. Which candy has higher sugar content? Airheads or Baby Ruth? Oof. The role of sugar. Do people tend to prefer candies with higher sugar content? So in that case, you pick the candy category. Is there such a category? No, this is all candies. Okay, you plot brand versus sugar content. No, wait. What you do is you do you definitely, what is it? Sugar content, prefer candy higher sugar content. You do sugar content, win percent. Yeah, win percent on the y-axis, sugar content on the x-axis. So, and the names are your data points. So you plot, okay, what is the win percent of 100 grand and your X value is the sugar percent. So this will like give you some type of trend. So if that is true, then higher the sugar content. So it will be here on the x-axis. So 0, 1. Higher the sugar content. So for example, airheads, it should have the highest win percent, which seems like it's not. So then you scatter plot and then you put a trend line, and if you see a correlation and if the correlation is significant, there you go. Okay, so let's go back to the example. To create a simple scatter plot, we use SNS scatter plot command and specify the values. Okay, so SNS scatter plot parenthesis X equals insurance data BMI and Y equals insurance data charges. Okay. And I don't see anything about labels. And here it puts the regression. SNS reg plot on the same thing. So we overlap So instead of adding a regression or trend line, this basically, let's see, the plot above suggests BMI. At the regression, okay, it says at the regression line, but seems like this is just another type of plot. Anyways, let's go. So SNS dot scatter plot X is, ooh, okay, the data, sugar percent, and is it, yeah, and then y equals candy data win percent. And we do that. If I would put a trend line, it would be like, phew. There's this slight, very slight increase. Like this part, if you see here, this part is empty. So I guess maybe instead of just being completely flat, it will be skewed, like it will be inclined just a little bit. Okay. Does the scatter plot show a strong correlation between the two variables? No. If so, are candies with more sugar relatively more or less popular with sugar survey respondents? Uh, bum, 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 bum. So, okay, well, I was gonna do the regression, but it asks us to do later. So I say no. I say it doesn't really matter at all. I don't see any correlation. What does this say? Yes. Take a closer look. Scatter plot with regression line showing the relationship between sugar percent and win percent. SNS reg plot, and we're gonna do basically the same thing. The data and data. Yeah. So. I wish you told me what is the shadow. BMI charges. What was it? Something fell down on the AC unit from outside. Anyways. Okay. So this is different. Data, insurance data. So here we specify the data and then we directly give the column names. I'll try something different, okay? I'll try to do the same thing with works. Plot above, is there a slight correlation? According to the plot above, is there a slight correlation between win percent and sugar percent? What does this tell you about the candy that people tend to prefer? So there's this really slight correlation. And honestly, I know this is a simple example, but usually this is not enough. This depends on the field you're studying, how much data you have to to draw information from such graph. You might have to do some additional tests. I don't think that this is a nice way of doing statistics just by looking at the regression graph. But okay, so for this question, it tells me that there's a slight correlation, although it might not be significant, we don't know, but we just ignore that. And what does this tell us? That people tend to like sweeter candy bars or candies. Okay, in the code below, create a scatter plot to show the difference, the relationship between price percent and win percent. Use the chocolate column to color code the points. Scatter plot. My x-axis is, let's try what we learned before. Y is win, and then chocolate, pew, weird, like. Price percent, win percent. Can you see any interesting patterns in the scatter plot? So what I see If there's chocolate, then price percent, I guess I would say increase. So if there's chocolate, then there's a positive correlation, slight to moderate positive correlation between price percent and win percent. So as the price increase, the win percent increase. But if there's no chocolate, then it's a negative correlation between win percent and price percent. So if there's no chocolate, the win percent decrease as the price percent increase. Create the same scatter plot you created in step 5, but with two regression lines. SNS LM plot X being what was it? 5% Y being 20% and data being candy data. Oops. Okay. Use the regression lines. Using the regression lines, what conclusions can you draw about the effects of chocolate and price on candy popularity? So if there's no chocolate in the candy, then when the price increase, the win percent decrease. So people are less likely to like it. When there is chocolate in the candy, people like pricier chocolates more. It might be because as the price increase in chocolate candies, the chocolate quality goes higher, so that might be affecting the likes of people. We'll begin with the regression line for chocolate candy. Since the line is like positive, we can say that more expensive chocolate candies tend to be more popular. Likewise, since the regression line for candies without chocolate has a negative slope. What to note, however, is that the data set is quite small here. So we shouldn't invest too much to trust in this. To inspire more confidence in the results, we should add more candies to the data set. Okay. And 7, everybody loves chocolate. Create a categorical scatter plot to highlight the relationship between chocolate and win percent. Chocolate on the x-axis, win percent on the y-axis. So smoker, yes, no. So then the variable should be categorical. This also shows the clusters, like where they are. Look at that. This is like a pine tree. Has two. So the range from 15 to 30 is one group. From 32 to 50 is another. Here, from like to 1000 maybe to 18, 15 to 18 is one group, and here's another one. So swarm plot. Okay, okay. Scatter plot showing relationship. Chocolate and 1%. So chocolate, is it categorical? Yes. S and S dot swarm plot equals X Y when percent data. Hmm. Oh. Boo. So chocolate, no. So chocolate definitely affects the win percent. Okay. You decide to dedicate a section of your report to the fact that chocolate candies tend to be more popular than candies without chocolate. Which plot is more appropriate to tell this story? The plot from step 6 or the plot from step 7? Step 6 is this. Step 7 is this. To me, I would go with this because it's cleaner, it's easier to see. Um, Yeah. Yes. Noise. Okay, okay. Distributions. Select a data set. We will work with a data set of 150 different flowers for 50 each from these three different species of Iris setosa, Iris versicolor, and Iris virginica. Seems like there's not much difference. So you load the data, and index column is ID. You print the data and you check for sepal length, sepal width, petal length, petal width, and then species. And then let's do that first. Real data set, microscope images of breast cancer tumors. Each tumor has been labeled as either benign or malignant. Okay. Data set up. Dum, 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 dum. Dum, 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 dum. Drum, 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 drum. So there's the agnosis. Okay, radius, texture, perimeter, area, smoothness, compactness, concave point. So there are geometrical attributes here or features, and for mean, for average, and then worst, I guess. So symmetry mean, symmetry worst. So let's look at area. Area 566.3 mean, area worst. Okay, so worst is like the highest. Okay, and for the other one, ooh, look at the area. These are a lot larger. Also this, I guess smooth is also worst, although it's not a great way to group them, I guess. Look at area. Wow. Da, 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 da. In the first 5 rows of the data of benign tumors. Okay, let's do this. Let's do a trick from what we've learned. Cancer, the data dot ilog dot ilog 0. Didn't work for some reason. Anyway, I probably did something wrong, but okay. Perimeter. Benign data. Largest mean 99.7. Radius mean of 84, 25, 17. 84, 25, 17. Radius 20.57. largest max. Benign. Oh, sorry. 87, 46. SNS dist plot, distribution plot, and A iris data, petal length. KDE false. Bum, bum, bum. This part is made me confused. Yes. What? Now that I found you, even the light. Oh, even the days are brighter. Even the light even the nights are better since I found you. It has to be A. Interesting. Mm, 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 Whoa, even the days are brighter. Da, da, da. Mm. Even the nights are better since I found you. Mm. So, a researcher comes to me, the newbie data scientist, and says, how can we use this area column to differentiate between benign and malignant tumors? So, and I look at the histogram and I ask myself, do malignant tumors have higher or lower values for area relative to benign tumors on average? I look at here for benign tumors, the mean is around 3 something hundred. And I look at the malignant tumors and the mean is around like 900. I say, hey, dude, look, the means are really different. Seems like it from the graph, but I don't know how much data you have, so I can't say for sure. But seems like if you have enough data, the means are really different. So yeah, the malignant tumors have higher mean area than benign tumors. So and the malignant tumors, the range for them is a lot higher. Use the code cell below to create two KDE plots that shows distribution in values for radius worst for both benign and malignant tumors. KDE plots. Next type of plot is kernel density estimate. I haven't heard it before. In case you're not familiar with KDE, yes, you can think of it as a smoothed histogram. To make a KDE plot, we use the SNS KDE plot command. Setting shade equals true colors the area below the curve. Nice, nice, nice. And data equals has identical functionality. Okay. Nice. So what might I remember? Let's say I'm writing KD SNS.KD plot parentheses, and inside I put data equals, and I put the name of the data set, and then in square brackets, and then quotes, I put the name of the column, and then outside the square brackets, I put comma, and then shade equals true. Okay, I would forget the shade. So shade equals true. Okay, shade equals true. Okay. We are not restricted to a single column when creating a KD plot. We can create a two-dimensional KD plot with SNS joint plot. In the plot below, the color coding shows us how likely we are to see different combinations of sepal width and petal length. And petal length. Kind. Oh, important. Kind. KDE. Okay. Let's see how much of this we can retrieve back from memory. Use the code cell below to create two KD plots. So two different KD plots. Plot.kde plot. No. SNS.kde plot. Data equals. Okay. That shows distribution in values for radius worst for benign. Sorry. Equals. Oh. Every time. Wait, I just did one. Malignant. Oh, that's it? I didn't do 2KD. I didn't do color plot. Come on. Come on. Okay. Mm, let's play. Let's play. Let's do the joint plot. Um, X. Bum 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 bum. Ba 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 bum. Ba ba bum 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 ba bum. Da 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 da. Lost in your eyes, yeah. Listen to your heart. Listen to your heart. There's nothing else you can do. I don't know where you're going, and I don't know why. Listen to your heart. Before you tell him goodbye. Bum, ba-da-bum, bum, ba-da-ba-da-ba-da-bum, bum. What does this tell? When we look at distribution for benign tumors, the distribution of area of benign tumors, the mean area is around 400, and mean perimeter is around like 80. So what might happen? We might had different data points like many places, but we expect them to fall in here, right? We expect them to be here. So this is like Can this be like a regression line? Points scattered around it? Probably, because this area, like 400 benign tumors with 400 mean area, is highest in number in this data set, and for this is 80. So if it's the same data set, then 400s and 80s should kind of match. And so they should fall somewhere here, like here. Interesting. Interesting. Okay. Finally, what is this? Color coded plots. For the next part of create plots to understand species. That's the KD, that's the smoothing. Da, 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 da. Da, 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 da. Da, 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 da. Da, 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 da. Da, 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 da. Dum, 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 drabadabum, dum, dum, dabadabum, dabadabadabum, dum, dum, dabadabum, dabadabadabum, dum, 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 dabadabadabum, dum, 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 dum. Do, 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 do. Da, 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 da. Da, 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 da. Da, 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 da. Boom, 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 boom. Rum, rum, bura, rum, bura, 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 bum, bum. Okay, this is not too different actually. Okay, I guess we're good. Good, good, good. Choosing plot type. Oh. What would you like to show? I like this. What would you like to show? If you like to show distribution, then you can do joint plot. This is really cool. I guess this is shade turned on. You can do KDE plot that can show distributions, smooth it, or you can do a synesthetic plot. If you want to show relationships, you can do relationships. This is a vague word. If you want to do trends, do line plot. Okay. Relationships. Heat map. You can do heat map. You can do bar plot. So let's dig in deeper. If you do scatter plot, you're like almost doing regression. Yes. If you're doing swarm plot, then you have a categorical variable versus some other value. So relationship between this categorical behavior and that continuous other behavior. If you're doing heat map, then you're showing three things in two dimensions, two continuous variable, and then a third property. You're doing bar plot, you're showing the relationship of magnitudes of properties. Okay. Let's go. Somebody else's lover, I forgot to look in your eyes. First I have to discover your eyes. Somebody else's lover, 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 boom, boom, boom. Somebody else's lover.
Hi, today I'm going to show you how to upload a data set to Kaggle. So I'm here on my Kaggle homepage. I've logged in. I'm going to go to datasets and then create new data set. And here it will open a dialog box, and you'll see that I have several different options for uploading a data set. So if I have a remote file at a URL, I can use the URL. I can import an entire GitHub repository, or I can create a data set from a kernel, the kernel output file. But today I'm going to do the simple one, and I'm going to call this mock data. And then I have a CSV file that I've downloaded here. So I'm just going to drag and drop that CSV file into my data set and hit create. If I wanted to upload more files, I could use this upload more files button instead. And then it'll take just a little bit to upload your data set and create the page. Now that I've uploaded my data set, I can go to data set and I can create a new notebook and start coding right away using the data that I've uploaded. I hope you found this helpful. I have been Rachel Tapman from Kaggle.com, and I will see you on Kaggle. Bye.
Someone is calling me, so I have to pause. Hello back. Okay, let's do this quickly, and I have to go. Where's add data? I guess you do this. Okay. Mm, 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 mm. Oh. Ooh, ooh. What did I do? No. Mm, 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 mm. I'm really tired, I guess. Categorical. Okay, look, do a categorical, like do Hmm. Hmm. Instead, let's do death event and then do my data serum sodium and then do mm, 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 mm. Hmm. 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 These don't tell much. I guess we should look more categorically. Okay, that's it for now. I have a meeting, so I gotta go, but see you next time.